Hello, my name is Luis Silva and my purpose here is to give you a brief explanation about my master thesis subject, whose title is Microwave Plasmas Applied for Synthesis of Freestanding Carbon Nanostructures. That's a long title, right? But let me give you some insight about it. The first thing I would like to go through is the concept of plasma. Also known as the fourth state of matter, it consists in a high-temperature collection of charged particles, such as electrons and ions, that come in equal number. A plasma shares some of the properties of a gas, but it differs from it by being a good electricity conductor. Microwaves are just the power source used to heat up the gas up to the plasma state. Now you may be wondering, what do I mean with carbon nanostructures? A carbon nanostructure is, as its name may indicate, a nanometric scale material composed by carbon atoms. Diamond and graphite may be known examples by you of carbon materials. But one of the most recent additions to the list is graphene, a flat monolayer of carbon atoms which are tightly packed into a two-dimensional hexagonal lattice structure where each carbon atom is bounded to three others. It's like a sheet of paper whose thickness is just one atom. It's the perfect 2D material. Graphene is an amazing material. It's the material of superlatives. It's the strongest material we know, even stronger than diamond itself. If I had a hammock of graphene here, I could put a baby on it and it would rest in thin air. Another property is that it has just surface and no height. But still, if you put a substance on its surface, it won't let it through. With just 15 kilograms, you could cover all: the computer, tablets, iPads and mobile phones displays with graphene. It's also one of the best thermal and electricity conductor. For these reasons, graphene and more recently a doped version of it with nitrogen are a prime choice for alternative energy conversion and storage applications such as batteries, fuel cells, solar cells and supercapacitors elements. Now that I convinced you that graphene may be a very good solution to a more sustainable future, you say, so let's produce it. But there's the real challenge. The applications I mentioned before require graphene in a very pure form, with no contamination from other species, and in a substrate-free state, I mean freestanding. Therefore, a scalable and reproducible method is the way to go. Multiple processes have been reported for graphene synthesis, including something as simple as exfoliating graphite and other chemical processes. However, those methods are expensive, have low production rates, are multi-step and allow the presence of impurities, compromising the quality of the resulting material. More recently, plasma-based nanofabrication methods are spreading around. Due to its characteristics, plasma systems provide a highly reactive environment, which makes it the perfect route for nanoscale assembling of materials. In my thesis project, I will study the application of a microwave plasma to synthesize carbon nanostructures, including graphene. It is a single-step, scalable and large-scale fabrication method that starts with the injection of carbon sources such as alcohol, methane and even carbon dioxide at the top of the plasma and ends up with carbon solid structures at the bottom. It's like the ancient alchemists trying to produce gold from rock, but here, using cheap gas or liquid substances, we can produce those valuable carbon materials, which I'm sure will shape our future. But don't get tricked, it's just physics.